everyone. Today we're doing notes on 2.1 frequency distributions, histograms, and related topics. So frequency table, this separates data into classes or intervals of equal width. It shows how many data values are in each class. Classes are constructed so that each data value falls into exactly one class. So we find the smallest data value and the largest, then we find the difference. To get the class width, you divide this number by the number of classes wanted and round the resulting number up. So we take our largest minus the smallest and divide by the number of classes wanted. And then you make sure to round that resulting number up. Your lower class limit is the smallest number. The next lower class is this number plus the width found above. Go through the data telling how many data values belong in each class. So suppose we have a sample of 18 students and their heights in inches are as follows. We can see our largest value is 75. The smallest is 63. So if we take the difference, 75 minus 63, and then it says we want to use 5 classes. So I'm going to divide by 5. That gives us 2.4, which we need to round up to 3. So the first lower class limit is 63, our smallest number. Then you add 3. So you can see 63 plus 3 gives you 66, the next lower class number. Add 3 again, 69, 72, 75. And then we fill in the upper class limits. So that'd be 63 to 65, 66 to 68, and so forth. The midpoint of a class is the lower limit plus the upper limit divided by 2. So in our example, we have that these midpoints would be 64, 67, 70, 73, and 76. Class boundaries are 0.5 less and more than the class limit. So I'm going to label this on our chart right here. So our class boundaries, if I go 0.5 below, this will be 62.5 through 0.5 above is 65.5. For the next one, 66, if I go 0.5 below, we get 65.5. So if you notice the class boundaries, the upper boundary of one class is the exact same as the lower boundary of the next class. Okay, so if you're doing this correct, those numbers should be the same. So this is through 68.5, then 68.5 through 71.5, 71.5 through 74.5, 74.5 through 77.5. Okay. Then the relative frequency, this is found by dividing each frequency by the total number of data points. So frequency, if I count this, our total is 18. So for relative frequency, we divide these. And if you notice, our relative frequency, this will always add up to 1. All right, so now draw a histogram based on the table. So I'm going to use our class boundaries. This was an example they had given from the book. The class boundaries are actually what you will use to label the x-axis. So this is 62.5, this is 65.5, then 68.5, 71.5, 74.5, and 77.5. Okay. Then we notice our y-axis. This is the frequency. And so it says a histogram. This is a bar graph where the bars are centered on the midpoints of the classes and the heights are the frequencies. So first one has a frequency of 3, 5, 6, 3, and 1. I like to label them on top as well, just to make it very obvious what the height of each bar should be corresponding to. So our first bar is centered on 64, goes from 62.5 to 65.5. Again, for me, this is more important that what your starting and end, those class boundaries are. That's what I want you labeling the x-axis with. And the height of this bar is 3. Now, a relative frequency histogram. This is a bar graph where the bars are centered on the midpoints of the classes and the heights are the relative frequencies. So if you notice, it's going to be the same bar graph, but in this case, the heights are not the frequencies, but the relative frequencies, which is our last column of the table. So now our y-axis becomes relative frequencies. And so if I'm looking at my table, the first one we see it's 0.167. Then we have 0.278, 0.333, 0.167, and 0.056. Notice the shape is the same. Your x-axis, again, we're using the class boundaries, so 62.5, 65.5, 68.5, 71.5, 74.5, and 77.5. Again, the only thing different is the y-axis. The shape looks the same. The heights of the bars in relation to each other are the same. Okay, it's just you're changing from frequency to relative frequency. So all of those values were divided by 18. All right, so practice 1. It says, an irate customer called Dollar Day Mail Order Company 40 times during the last 2 weeks to see why his order had not arrived. Each time he called, he recorded the length of time he was put on hold before being allowed to talk to a customer service representative. So here's the length of time on hold in minutes. So A says, what are the largest and smallest values in the table? If we want 5 classes in a frequency table, what should the class width be? Please find this now. Okay, our smallest value, if we're looking, is 1. Our largest value is 13. So I'm going to list these. Largest is 13. Smallest is 1. And so we want 5 classes. So we're going to do 13 minus 1 divided by 5. That comes out to be 2.4. So our class width will be 3. Let's complete the frequency table. So we have 1 plus 3 is 4, plus 3 is 7. Add 3 again, we have 10. Add 3 again, we have 13 for all of our lower limits. Then our upper limits, we have 3, 6, 9, 12, and 15. So let's tally these out. I'll give you a minute to go ahead and tally these, and then I'll fill in the tally chart. Okay, you will find that there are 3 for the first class. There are 15 for the second class. There are 17 for the third class. There are 4 for the fourth class. And 1 for the last class. Okay, the midpoint of each of these, if I have class limits of 1 and 3, the midpoint is 2. For the next one, it would be 5, then 8, 11, and 14. It says, recall that the class boundary is halfway between the upper limit of one class and the lower limit of the next. Use this fact to find the class boundaries in the table below and to complete the partial histogram on the right. So our class limits, we had from 1 to 3, 4 to 6, 7 through 9, 10 through 12, and 13 through 15. So our class boundaries are 0.5 to 3.5, 3.5 to 6.5, 6.5 through 9.5. Then we'll have 9.5 through 12.5 and 12.5 through 15.5. So again, we use the class boundaries to label the x-axis. And let's complete this histogram. So the height of the first bar is 3. The height of the second bar is 15. We found the next one from 6.5 to 9.5. The height is 17. So we're going to complete that bar. Next, the height from 9.5 to 12.5, the frequency is 4. And the last one, from 12.5 to 15.5, this had a frequency or height of 1. And now that histogram is complete. Okay, it says compute the relative frequency for each class in the table below and complete the partial relative frequency histogram. So I'm going to actually change this to class boundaries. And so we're going to copy these from above here. So we have 0.5 through 3.5, 3.5 through 6.5. Then we have 6.5 through 9.5, 9.5 through 12.5, 12.5 through 15.5. Now our relative class frequencies, I'm going to list the frequencies. We had 3, 15, then we had 17, 4, and 1. The total we know is 40, so we're going to divide each of these by 40. Our first two relative frequencies were given to us. This first one was 0.075. The second one was 0.375. The third one, 17 divided by 40. This is 0.425. So then we're going to draw this in on our graph. So this is 0.425. Our next bar, 4 divided by 40 is 0.1. It's going to look like this. And last 1 divided by 40 is 0.025. And so our last bar for our last class will be here at 0.025. All right, according to the graphs, about what percentage of the hold times are between 7 and 9 minutes? Would it be unusual for the hold times to be less than 4 minutes or greater than 12? I would like you to answer this, please. Okay, so if we're looking at between 7 and 9 minutes, that is this bar right here. So that's going to be 42.5% are between 7 and 9 minutes. The next part, it says, would it be unusual for the hold times to be less than 4 minutes or greater than 12? So less than 4 would be anything from this first column. Greater than 12 would be anything in this last column. So less than 4 that's 7.5%. More than 12 minutes is 2.5%. So if we're talking about or, we're saying it could be either of these. So total, this is only 10%. So yes, that would be unusual. Shapes of distributions. So the first shape we're looking at is mound-shaped symmetric histogram. This is one where the tallest bars are in the middle and the other heights decrease symmetrically on either side. A uniform or rectangular histogram, this is where the heights of the bars are all the same. We have a bimodal histogram. These are two separate places where there are the tallest bars. So bimodal, meaning there are two modes or two peaks that you will see. Next, we have a skewed histogram. This is where the tallest bars are not in the middle, but on the left or right of the histogram. So skewed right, this is if the tallest bar is on the left, then we say the graph has a tail on the right. Skewed left, this is if the tallest bar is on the right, then the tail is on the left. So when we're describing skew, the skew follows the tail. So again, looking at the pictures here, skewed right, the tail is on the right of each of these graphs, if you see those tails, okay? Skewed left, we can see that we have the tail is on the left for each of these graphs. All right, so here is another practice problem. It says, medical tumor recurrence. Certain kinds of tumors tend to reoccur. The following data represent the lengths of time in months for a tumor to reoccur after chemotherapy. So it says we're going to use 5 classes to do the following, okay? So first we have to find the class width. So again, we're using 5 classes. Our largest number here is 59. Our smallest number is 1. So we do 59 minus 1 equals, actually let's write this in 1. 59 minus 1, and then we're going to divide that by 5. And so that's going to give us 11.6. So we're going to use 12. We need to make a frequency table showing our class limits, class boundaries, midpoint frequencies, and relative frequencies. So I will give you the data for this one. So our class limits, we start with our lowest is 1. If I add 12, that gives me 13, 25, 37, and 49 for all of the lower limits. So then my upper limits are 12, 24, 36, 48, and 60. Class boundaries, if you recall, we go 0.5 above and below. So this is 0.5 through 12.5, 12.5 through 24.5, 24.5 through 36.5, 36.5 through 48.5, 48.5 through 60.5. So for each of these, our tally, we end up with 6 for the first class, 10 for the second, 5 for the third, 13 for the fourth, and 8 for the last class. This is a total of 42. Midpoint, if I take my class limits, 1 plus 12 is 13, divided by 2 is 6.5. 13 and 24, that gives you 37, divided by 2 is 18.5. And continuing similarly, this is 30.5, 42.5, and 54.5. Relative frequencies, let's list our frequencies, 6, 10, 5, 13, and 8. And we're going to divide each of these by the total, 42. So your relative frequency is going down. we have 0.143, 0.238, 0.119, 0.310, and 0.190, which if you notice, that gives us a total of 1. Okay, so now we have to draw our histogram. So I'm going to label the x-axis using our class boundaries. So here we have 0.5, 12.5, 24.5, 36.5, 48.5, and 60.5. Our y-axis is going to be the frequency. And we see our highest frequency is 13. So let's count up that high. I'm labeling every 5, but counting by ones. Okay, so it's our frequency, our x-axis. This represents months. Okay, so the height of our first class is a frequency of 6. The second one, we have a height of 10. Our third class, we have 5. Next, we have 13. And our last class, we have a height of 8. Okay, for relative frequency histogram, again, remember our x-axis will be the same. So here we have 0.5, 12.5, 24.5, 36.5, 48.5, and 60.5. Our y-axis is now the relative frequency. If you notice, the largest number we have is 0.310. So I'm going to label, this is our relative frequency. So we have 0.1, 0.2, 0.3. Okay, so doing each of our relative frequencies, the first one we have is 0.143. Then we have 0.238. Next is 0.119. Then 0.310. And last we have 0.190. Okay. Categorize the basic distribution shape as uniform, mound-shaped symmetric, bimodal, skewed left, or skewed right. Please answer this question now. Okay, for this one, the correct answer is this is bimodal. Okay, you can see here we have 2 peaks on our data. Okay, the only other thing you could possibly argue, I'm going to say the modes are close. So you could also argue that the data is symmetric. Okay, there is a very big dip in the middle. However, you have those two modes and it looks symmetric on the opposite sides of that. So you could also argue that the data is bimodal, but symmetrically bimodal. All right, interpretation. Discuss some of the features about the data that the graphs reveal. Consider items such as data range, location of the middle half of the data, unusual values, outliers, etc. So our range here is from 1 to 59. So that's 1 month to almost 5 years. So that's a large range. The middle half falls from 13 to 48 months. And there are no outliers or unusual values. All right, cumulative frequency, the sum of the frequencies for that class and all previous classes. Cumulative frequencies tells us how many data values are smaller than an upper class boundary. Ogives, or cumulative relative frequency graphs. This is a graph where the data plotted on the graph are points where the x coordinates are the upper class boundaries of the classes and the y coordinates are the sums of the frequencies so far. How many data are less than the indicated value on the horizontal axis, and it shows how slowly or rapidly the data values accumulate over the range of the data. So how to make an ogive, or cumulative relative frequency histogram. You make a frequency table showing class boundaries and cumulative frequencies. For each class, make a dot above the upper class boundary at the height of the cumulative class frequency. The coordinates of the dots are the upper class boundary, comma, the cumulative class frequency. Connect these dots with line segments. By convention, an ogive begins on the horizontal axis at the lower class boundary of the first class. So we're going to do this for practice too. So I'm going to list our data here again. So we have our class boundaries. So we go from 0.5 to 12.5, then 12.5 to 24.5, 24.5 through 36.5, 36.5 through 48.5, and then 48.5 through 60.5. Okay, so if we are listing our frequencies, I'm going to put this in another color. So our frequencies we had were, if you recall, 6, 10, 5, 13, and 8. So now I need to find our cumulative frequencies. Okay, so our cumulative frequencies. First one is 6. Then 6 plus 10 is 16. Plus 5 is 21. Plus 13 is 34. Plus 8 is 42. So your last number should be your total. And now we need to find the cumulative relative frequencies. So our cumulative relative frequencies, now we're taking these cumulative frequencies and dividing by the total, which is 42. So the first one will be the same, 0.143. 16 divided by 42, this gives us 0.381. 21 out of 42 is 0.5. 34 out of 42 is 0.81. And then 42 out of 42 is 1. Now, if you want to write these as percents, remember you could always multiply by 100 for the percentage value. Okay? So let's draw the ogive here. My x-axis is still the months. So we have 0.5 to 12.5. Then, whoops. 24.5, 36.5, 48.5, and 60.5. Then we're going to list our cumulative frequencies. As our data points, okay? So we always start, let's see, our highest number is 42. So let's count by sixes here. So 6, 12, 18, 24, 30, 36, and 42. So our first point is 0, and that's going to be at 0.5. At 12.5, so at the end of that class boundary, our frequency is 6. At 24.5, our frequency is 12. At the end of the next one, at 36.5, we're at 21. At 48.5, we're at 34. And then at 60.5, we are at 42. And so then we connect our dots. The other thing, you can label these and do cumulative relative frequencies. So if you wanted to list this as the cumulative relative frequencies, you would have the percentages on the side. And then instead of these numbers, you would have here 0%. You could have 14%. This would be 38%, 50%, 81%, and 100%. Again, you can list either the cumulative frequency or the cumulative relative frequency. Okay. All right, our last practice. Here we are given ogives, and for each of these, it says labels on each point give the cumulative frequency and the cumulative percentage of data, which is the cumulative relative frequency. So it's just like listing both of these like we just did. That's what's given to us on these graphs. So we have to answer some questions. The first one says, in which distribution does the most data fall below 20.5? So let's look at the first graph. The first graph we can see at 20.5 we have 10%. So graph 1, it's 10%. Graph 2 we have 70%. And graph 3 we have 28%. So the most data that falls below 20.5, that occurs on graph 2. Our next question, in which distribution does the most data fall below 40.5? So 40.5 for the first graph is 30%. Our second graph at 40.5, we're at 90%. And our third graph, we have 94%. So in this case, the distribution with the most data below 40.5 is graph 3. Our last question, in which distribution does the amount of data below 20.5 most closely match that above 30.5? So now we're looking at the data that is above 30.5. So let's check this. Here, the first one at 30.5, there's 16%. So we have to think 16% is below 30.5, but we want above 30.5. So we have to do 100 minus the percentage shown. So 100 minus 16 tells us at graph 1, we have 84%. For graph 2, at 30.5, we see 84%. So we're going to do 100 minus 84, which tells us for graph 2, this is 16%. Then for graph 3, we see that we have 72%. So 100 minus 72, this is 28%. And so we're looking for in which distribution does the amount of data below 20.5, that's what we answered in the first question, most closely match that above 30.5. So if I'm comparing these two numbers, we can see that for graph 3, these are the closest. They're exactly the same, 28%. Okay, our last question. Which distribution seems to be skewed right, skewed left, and mound shape? I want you to please answer this one. Okay, our first graph, if you notice, we have bigger jumps towards the end of the graph, and it looks like we have smaller jumps towards the beginning of the graph on the left. What this means is this would look like we have a tail on the left. So graph 1 is skewed left. For the second graph, you can see we have large jumps in the beginning and then small gains at the end on the right, meaning that we would have a tail on the right. So our second graph is skewed right. Our third graph, if we're looking at it, if you notice the larger jumps are in the middle, and then we have small increases on the left and the right. So this one is going to be mound shaped. And that is the end of our notes for today.